Okay, let us see how we integrate by parts. I also accepted this question, that how do you handle this number here? It says evaluate the integral from pi over 3 to pi x sine x dx. So this is the number we can handle using integration by parts. We also cover the full topic of integration. You can list the pairs and then you find out all those things. Now, here there are two methods as I told you. You can use the one for formula, integration by parts formula, as is this how it's stated. Though some people put the x down here, the x, then the x, but that is it's also okay. But this one I think it works better. Then there's another technique which we call the basic technique. It also gives you the same answer, and I think it's always shorter, though some people don't know when to end. But this one I'm going to use the basic technique. Then you can use the integration by parts formula there. So all this, the basic technique, and then this, all of them I used to solve that. How this are they have to integrate, use integration by parts. Then we see that you have a product of two functions, which are very different. So an algebraic function, this is an algebraic function, and they open a polynomial. Then this is a trig function. When they are having the product, in most cases, they are not going to survive using integration by parts as long as there is no function and its derivative. So the idea is here, the method we use, the simple acronym we use is what we call the REACT method. This one stands for logarithm, inverse function, algebraic function, trig function, exponential function. Then what we need also is, you know, when you integrate sign, you get a negative of course. That is what you should know. Now we say, don't confuse integration and differentiation. We saw in the differentiate sign you get a positive cos, but this is now integration. When you integrate a sign, you get a negative cos. And then when you integrate a cos, you get a positive sign, which is the opposite in differentiation. So let me handle out this. What are you going to use? Or is the idea is in determining what u is and what v is. U, this is the acronym that is going to give you a simple life. U is the number that comes, is a function that comes first here. So when you depend on the function you have, you come and see which one comes first, it becomes the u. It means that it's the one, u means is the function which you are going, which is very easy to differentiate. It's a differentiable function. All of them are differentiable, but which one is easier is what is u. Then the v is the function that is very easy to integrate. As simple as that. So, you start here, we have two. This one is an algebraic function, and this is a trig function. And you see which one comes first. You see that here, when you compare, you see that algebraic function comes first before the trig function. So now this algebraic function, x becomes our u. So now our u is going to be x, then our dv is going to be now sine x dx. Those who are going to use this formula, you can able to use it. But me, I'm going to use the basic technique. So that here you can get the x. Now is that all you need the u and you need the v. When you integrate this, you get the v. When you integrate this, you get the du. As simple as that. And now let me use the basic technique. So the same idea, but the difference is, for instance, we are going to use a table. We have a sign here. We have the function is to differentiate. And then the function which is to integrate. As simple as that. So these are the basic things we use in the basic technique. Now, always is that always our u is the function we put here. This is a positive. The sign that you use first is positive, as you can see there, positive. Then the function is easier to differentiate is what we call our u. So this one is going to be our u, which is c. It's going to be x. Then the function is easier to differentiate. It's going to be our dv, which is now sine x. As simple as that. Now, this is the first step. Now this is what I have here. Positive x sine x. As long as some cases this will be the u, and then this will be the v, as we saw in the integration there. Now, these signs keep on alternating. So from a positive, I'll go to a negative. When I differentiate x, I get 1. When I integrate sign, I get negative. I integrate sign, I get a negative of cos x. That's the first step. Then in most cases, we do until when this one reaches 0. Or if the function is not going to come to an end, we do this until when the function we have here and here was the one which was given in the question. So, plus, now they are alternating from a negative now to positive. They differentiate to 1, we get a 0. But when you integrate, remember this is already negative, but instead when you integrate a sign, this negative is already there. But you know that when you integrate a cos, we get a positive sign x, because that was already there. So that is the case there. Now you start this one is a 0. The question is, how do we choose? So this is how you go. You get this, you get the sign, and this, then the product, you multiply it with that. So my integral, which is I there, now is going to be this times this positive x, then this times this, you get negative x cos x. Then you come to the next, this times this, I get that, negative 1. Then negative 1 times this, I will get, now this times this negative 1 times this, I'll be adding now positive sine x. Now I come to this like this times this, I get 0. 0 times this, I'll be having still 0. That's where in the moment that you have nothing, diagonal to this, then you stop there. So you stop at 0, times this which is going to give you 0. So that's why here I come and say, then plus my 0. But remember, this integral had limits. So I'm going to say now, so the integral from pi over 3 to pi. As simple as that. So this is our integral, which we have here. But if you forget this, the limits, and your I was equal to the thing without limits, then you're going to get 0 upon 0. So in most cases, if you don't want to forget, you let I be an integral without limits. Then after, you introduce this, and then you put in your limits. Now here, if you start our limits and radians, your calculus should also be in radians. You know that we substitute the upper limit, then minus when you substitute the lower limit. So let us do that. So now when I put in my upper limit, I'm going to be having now, I'm putting in now the upper limit we put in here, and then after subtracting, put in the lower limit. So here, when I put in my upper limit, I have negative pi. Then cos pi, then plus sine pi. So now I'll put the upper limit where there is x, where I put our upper limit. Pa, pa, pa. Then it grows. Then we subtract when we put in the lower limit. So when I put my lower limit here, I have negative pi over 3. Then cos pi over 3, where there is x, where we are putting that limit, this lower limit. Then plus sine pi over 3. Then we close our bracket. Then from here, can ably give your answer. So now from my integral of pi over 3 to pi of x sine x dx is going to be, now I press that on the calculator and you give to 4 decimal places. When your calculator is in radians, let me press mine. Okay, the answer I'm getting is 2.7992. I'm getting this to 4 decimal places. That's going to be my answer there. As simple as that. When your calculator is in variance, that's what we shall get. So, that's it. I wish you well. Then those who are using the other method, I can try, then I simplify for you. Also those who are using that. Remember, method 2. Method 2. Remember we said in method 2, our u is x, and then our dv is sine x dx. So when you differentiate to you, we are the dx, comma, when you integrate, dv equal to integral of sine x dx. So that here your b is going to be negative cos x. So we know that in our formula, integral from u dv is ub minus integral of v du. Our u from here is x. Then my dv, so that my dv sine x dx equaling to my u, which is x, minus dv, which is negative cos x, then minus my integral of b, which is negative cos x, then du, my du, is that equaling to dx. So now my integral of x, sine x dx is going to be negative x cos x. This negative and this negative give us a positive. So we have now adding an integrated cos, we get sine x. And I think you see we have exactly the same answer. And you see from there, which is the same as that there. And from there, I think you can ably put in your limits as you want. No problem. The same idea, then you put in the limits as we put them there. That's it. I wish you well. So that's how we use the two methods. Everything is going to be the same. This one, in most cases, it's easier. Okay.